Hello everyone, it's Paul with TutorU, and today we're going to have just a nice relaxing day. We're going to be going over algebra, simplification, combining like terms, distributive property, and I would say that's about it for today, right? So it should be about an hour long. We're going to cover those topics of simplification, distributive property, and then simplifying radical expressions. This is something I would say a lot of people struggle with these topics with algebra because it's hard to correlate the letters with numbers and to think of them as something that you can kind of play around with. So that's what we're going to do today. We're just going to play around with algebra, get you a little bit more comfortable with it, and it's always good practice for me. I love doing math. But I hope that this helps you with your pursuit of the GED math. And if it does, please let me know. And if you do like this content, if it helps you at all, I would greatly appreciate a like down below, a comment. You can comment. That's the benefit of having these live classes, and of subscribe. That will help this channel grow. It will help spread this helpful content, and I appreciate you guys. So let's just get started. So today it's just going to be example problems of working with these types of things. So the first thing, it's just a blank board we're starting with. So let's get going with that. The distributive property is what we're going to be doing first. And distributing, so what does it mean to distribute? When I say the word distribute, what do you think of? Like if I had 12 cookies and I wanted to distribute them to the class of 12 people, I would give each person one, correct? Well, what if I had 12 cookies and I had 24 people in the class? How would I distribute those cookies? Well, I could either give one to every other person, or I could split every cookie in half. Distributing in algebra is kind of similar in the sense that everybody is going to get something inside of certain groups. And that's what we're going to see. So let me pull up my sheet. I'm just going to be doing example problems. So let's go ahead and let's take a look at our first. So this is going to be distributive property. Distributive property in algebra. Okay. So our first example problem that we're going to be working with, nice, not too bad. It is, we'll change the colors up a little bit, keep it nice and fresh. So it's -3 and parentheses 9 minus 6k, end parentheses. And we're asked to distribute this, okay? So how would we go about doing that? I want to be able to monitor myself. So we're going to go on to my own stream so we can take a look at this. There, a little bit of echo, maybe a little bit of feedback, but okay. So before we get going, I want to highlight what is this. The letter K is our variable. It is a placeholder for a number. In this instance, and what I'm asking you to do is to distribute, we don't have to worry about that letter, right? We're not solving it. We're not trying to figure out what K is, so don't worry about the letter. Think of it as an unknown. It's an unknown variable, and it's just something that we're going to modify. So it's 6K. So those two terms are kind of tied together in a way. And we're going to modify the 6 to modify the K. We're going to play around with the 6 to be able to play around with the K. So we're going to distribute through the parentheses. So we have our parentheses here and here, and we're going to distribute this -3 by multiplication through the parentheses. So we're going to multiply. Each one of these lines kind of represents multiplication. So that first one, -3 times 9, what is -3 times 9? Negative 3 times 9 is a negative 27. Okay. And then a negative 3 times, now most people, they'll just go straight for this 6. But don't forget this minus sign. So it's like a minus 6. So what is a negative 3 times a minus 6? A negative times a negative is a positive. So 6 times 3 is 18. So we have a positive 18. Okay. And this is, so if you notice, there's no variable on this side of our two terms, and there is a variable over on this side. That means that we can't play around with this anymore. We can't simplify this expression any farther. We have our negative 27, which is just a real number, and we have our positive 18. We have a plus 18k. The 18 and the k are connected, they're interwoven at this time, and there's nothing more we can do with this expression. So we are done distributing. There's no more we can do to this problem. So let's go ahead and do another, oh, not purple. This is live, so I can't really edit that out. That's okay. So let's do another problem. I'll adjust my pen size. So we'll do negative 2 parentheses minus 7 plus 4x. So this is still the distributive property. We haven't moved on to anything else yet. So how are we going to go about distributing this negative 2 through the parentheses? And it's by multiplication still. Okay. So the first step, we'll break it down into step by step. So the first step we'll do in this pink color, and that's the negative 2 times the negative 7. So what is negative 2 times a negative 7? A negative times a negative is a positive. So that would be a positive 14. And then we'll do it in this kind of light green, our second step. And I think I'm good. I think you can see everything on the stream. So what is a negative 2 times 4x? A negative 2 times a 4x. And like I've said, people really struggle with these variables, with these letters being connected to numbers. But just think of it like this. If, oh, that's a horrible example I just thought of. It's bad. Okay, you have two people that are connected by some means, right? They're connected, maybe they're best friends. If you mess with one, it will change the other, right? So think of the 4 and the x as best friends. And if you mess with the 4, it will change the x without changing the way it looks, right? So what we're going to do is just multiply the negative 2 times the positive 4, and that's it. We don't have to touch that variable. So what is a negative 2 times 4? That is a negative, not a positive. It is a negative 8x. So are we done? That's what you should ask yourself, right? Is there anything more we can do to this? Well, we have our regular integer, and then we have this expression over here of 8x. There's nothing else we can do. We cannot distribute. We cannot simplify. All they asked us to do is distribute, okay? Or to simplify this expression. And we've successfully done that. So we're good. We are done. And let's just, oh, green now. It's like a party in here. Take you back to EDC. Okay, so let's move on to our next example problem. That is 7, that's the number 7, times a negative 6y plus 2. Okay, so now you can pause this, right? It's a live stream, but you can pause this. Go ahead and pause this and complete this problem. I want you to distribute. distribute this expression, or simplify. Simplify this expression. And let me know what you get, right? Like, so if you were to do that, so pause. Okay, I'm assuming you've paused now, and now you are going to play again. Our first step is 7 times the negative 6, and 7 times a negative 6. So what is 7 times a negative 6? That would be, let's think here, that would be a negative 42y, because a positive times a negative is a negative. And then your second step is this 7 times the 2. And so what is 7 times 2? It is 14, so it's plus 14. There's nothing more we can do to this problem. We are done. Easy peasy, lemon squeezy. We have completed this process. And again, because why not? We can keep things rolling. Oh. Let's add a new layer. Turn it all black. And we will move on to another distributive property. This one will look a little bit more challenging because it looks a little bit different than the rest of our problems. So we have 8 parentheses negative 6z, okay, plus 7 parentheses plus 9z. Okay. So now we have two. We still only have technically one variable, but we have it twice. But don't worry about that yet. A lot of people, they're just like, oh my gosh, there's letters, and they look at the whole problem. Don't even think about it. It's really, you want to just kind of tone your brain down. You don't want to overthink these things. So just stick to what we've been doing. Distribute first. So distribute that 8 times the negative 6z. So what is 8 times the negative 6? 6 times 8 is 48, so it's a negative 48 z. Bring your letter down. Plus, what's 8 times 7? 8 times 7, so that's just one more 8 that we have, so that is 56. And then you just bring down your last term here, so it's plus 9z. And then what I'm going to do is I'm going to rearrange this expression where my letters are next to each other. Okay, I want to rearrange this where my letters are next to each other, so we have a negative 48z and plus 9z plus 56. So now what we'll do is combine like terms. So if we were to combine these like terms, how would we go about doing this? Well, we have a negative 48z and plus 9z. So think of it like this. You are $48 in debt. You owe me $48. Joe Schmo comes up, gives you $9. Well, now you can pay back part of your debt to me. And that's what we're going to do with the letter Z. Hey man, you owe me 48 Z's. Oh, I only have 9 Z's. Well, pay me your 9 Z's now. So if you pay me your 9 Z's, so that would be a negative 39. So this is what I did. I did negative 48 plus the positive 9, and that equals negative 39. Okay. So negative 39z plus 56 . Wait. What do you mean you can't hear me? Did you pause the video or? Oh no. Everything looks good on my end. Let me see. Everything looks good on my end. Yeah, no, I have sound on my end. I'm good. Okay. So, negative 39z plus 56. And then, is there anything more we can do? No, there isn't. So we circle our answer. And we're good. That's done. You can hear me? You can hear me export? Sound is good? Good. Yeah. Yeah, I adjusted my microphone and everything, so I should be good to go. And also, I think it would be a good time right now. First off, if this stuff helps you, make sure you hit the like button. That spreads it in their algorithm, so more people will kind of pop in here, and they might see me. And on top of that, the other part is, I think after today, I'm going to take another short break because I'll be leaving the country in like less than 2 weeks. In 10 days, I'll be out of the United States. If you would like, I'm going to actually create I've created a travel blog or a vlog, a travel channel. So if you want to follow along as I go across to the other side of the planet and come along with me, that would be pretty cool. Let me put it in the chat here. Hang on. Let's go to here. And I'm just going to share it in the chat right now if I can. Let's find it. I can't find it. What the heck? YouTube? No. Where did it go? I shared it with somebody, so I can recover it. So there it is. Oh. That's weird. It's saying that my channel doesn't exist. 1 second, guys. Let me I want to actually check that out. See what happened. Why did it happen? Oh, do you know what? We're just gonna go with the rest of the class. I will post. So I don't have the ability to do posts on YouTube, but it's gonna be like Banana Ketchup Bebe is the name of it, and I might post it in the chat near when we get to the end of the class. Okay, I'll try to find it, but that's so bizarre that it is not there. Let's see. I wonder what happened to it. Anyways, I will be doing a travel channel. If anything, I'll come back on here tomorrow and I'll just do a quick little let you guys know, and I'll put that video up. So let's go on to another example of just this distributive property and different things that we can see with this. Okay. So let's create a new layer. We'll black it out. And we're good to rock and roll. So our next example problem is 3 parentheses -7 plus 8c end parentheses minus 2c. 2 weeks away. Yeah, I mean, so I'll say this. You are export, you're doing very well, right? Like, you are seeking out information, you are trying to find as much help as possible, and that in and of itself is a very good sign. That is really the key to the GED, that is the key to furthering your education, is that you yourself are reaching for the information. So I have faith in you doing well on that GED test. if you haven't already, if you go on to your GED account, if you've made one, you can take a practice test. And if you're feeling nervous, I would recommend you take that practice test maybe this week sometime, okay? You take that practice test and you see how you're doing. And then we'll just see how it is, right? You want to be, I would say, if you take that practice test, ideally you want to be in that 148 to 150 range for your score on the practice test. And if you're in that 148 to 150 range, you're usually pretty good to go. Just make sure you still study a little bit before the exam. But yep, you want to be right there, 148, 150, and you're good to rock and roll. And normally, in my experience is if someone tests right at the 145, that's the minimum passing score for the GED, it's usually a 50-50 chance on whether they pass or fail, to put that into perspective. But if you score in that 150 range, it's like a 90% chance, 90 to 95% chance you'll pass. So it's a lot better. As long as you're up above 145, you're doing okay. So just like the other problems, we distribute the 3 through the parentheses through multiplication, or with multiplication. And so 3 times the -7 is a -21. And then plus 3 times the 8c, that is 24. Oh, whoa. 24c minus, drop down the 2c. So 24 c's, take away 2 c's. Our end problem here, our end expression is -21 plus 22c. We took away the 2 c's from the 24 c's. Okay, not too bad. This stuff is pretty nice. We'll do one more of these, and then I'll move on to another type of question, or a little bit different. So add, black out. Okay, this will be our last one for the distributive property. It is 3 minus 9 parentheses 6m plus 8. Okay, and just like any of the other ones that we've worked with, this is your variable. Don't worry about your variable. We're just simplifying. If I ask you to simplify, distribute, I'm not asking you for the answer, so don't worry about that letter, okay? Don't think about the variable. And just like any of the other ones, I forget about 90% of the math, right? Like, there's all of this stuff on the screen. I don't worry about it. All I think about is, okay, what's the first step I have to do? I have to distribute. So you just distribute, okay? So what's 9 times 6? 9 times 6 is 54. But the 6 is connected. The 6 is connected to the m. So that is going to come down with it. Plus 9 times, hang on. Let's distribute this minus sign with this stuff. So this will be a negative 54m. And oh no, what happened? It looks all gross now. Okay, so it'll be a negative 54m. PEMDAS is not needed for those types of examples, right? Not really. No. Nope. Because, well, yeah, no, because you're like modifying it. So the way I think of it, like PEMDAS, right? Your parentheses, exponents, multiplication, division, addition, subtraction, that's all arithmetic. And usually with arithmetic, you're solving your equation, you're solving for an answer when you actually really have to do the arithmetic. And then there's this other part to algebra. The way I really view algebra is that it's the movement. It's the movement of things, right? We can shift things around, make them look different, but it means the same thing. So we've distributed the -9 through the parentheses. I brought this minus sign, kind of like think of it mentally, like I brought it closer to the 9, and I distribute it through the first part of the parentheses. So now I have to do -9 times the 8. And so -9 times the 8 is -72. Okay. And then we're just going to bring this 3. Okay, where should we put this 3 at? Do. Mana. Actually, yeah, I just bring it down. Yep. Okay. So we have 3 minus 54m minus 72. So 3. So let's put everything a little bit closer. Put your things like terms closer. So I'm going to move this 3 over here. I'm going to bring it way back over here. And it's a positive 3. So we have a minus 54m minus 72. Okay. And then plus 3. So all I've done is I've just moved that positive 3 back to the backside of this expression. And then we can simplify. So is there any other term that has a variable? No. So that means that we don't touch it. We don't mess with it. It stays the minus 54m. Now what we have left is we have a minus 72 and a plus 3. So you owe me $72. You found $3 on the ground. You like to pay off your debts. What do you owe me now? Well, you owe me $69. So minus 69. Okay. And then you ask yourself, is there anything more we can do to this problem? This term, our first term, has a variable. Our second term is just an integer. There's no more. Oh, the very first step. Yep, I can do that. So this is our end answer, though, and we'll talk about the first step. Okay. So the very first step is, and I changed it on you, and I think that's why you're asking about it. So we have the minus 9, and what I did is I distributed. I wanted to keep that minus 9, right? It's very easy. If we don't keep that minus 9 together, you can lose a negative sign. Okay. So what I wanted to do is take that minus 9, and I distributed this entire. I'm gonna circle it with a little green dots. This entire minus 9, I multiplied it by the 6, and so 6 times 9 is 54, but it's a minus 54. Okay. And then I took the negative 9 again, and I multiplied it by the 8. And so minus 9 times the 8 is the minus 72. So the other part is why people sometimes get a little bit flustered with that is listen. So I want to say this again, but just listen to the words that I'm saying. Okay. So a minus 9 times the 6m is a negative 54m. Like the word negative and minus, they're very like they can be interchangeable, right? So let's just take this for an example. So like 7 minus 5, right? Well, another way of thinking of this is 7 plus a negative 5. It's the same thing. So I think of things in this way. It's movable, because once you start thinking of things this way, math becomes much more powerful, right? So that's how we got the minus 54m, the first distribution through the parentheses, and then the minus 72 is the second distribution through the parentheses. And then this 3, I moved it to the back. It's a positive 3. There's no negative sign out front. Yeah. Yep. So you're feeling a little bit better with that, so that's good. The other part here, okay, is like this is super powerful. And so here this is a little Paul tidbit. Okay? When you think about it, when you're little, when you're first starting off in grade school, you're learning about subtraction. You're like, hey, 7 minus 5, that equals 2. I'm smart. And then like they throw, like you're learning addition, where like 3 plus 4 equals 7, right? Well, and 4 plus 3 equals 7. And we learn that, hey, you can move these two things around all the time. All the time you can bounce them back and forth. And so I distinctly remember learning subtraction. And it's like, okay, 7 minus 5, that equals 2. And you know what? 5 minus 7. Well, like little me, right? What did little me think? Little me was like, yeah, that's 2, dudes. That's 2. But it's not. It's not. What is 5 minus 7? 5 minus 7 is a negative 2. Big problem. And it's actually a hint that there's a problem in math, or in our studies of math. Subtraction is just a made-up thing. It's not like a real thing. Same with division, but I won't get into that. That's a deep kind of topic. But subtraction is just another way of writing this. So like the best way to think of it is this is the original, the 7 plus a minus 5. But math people assumed that people would never get that they wouldn't understand it. So they changed the terms to subtraction. They're like, hey, 7 minus 5, not 7 plus a negative 5. People won't understand it. But this is how it all functions, or this is how it should function, because, check this out. So 7 plus a negative 5 equals a positive 2, and a negative 5 plus a 7 equals 2. So notice how both of these expressions mapped to the 2, right? So that shows that you can move things around and it still gives you the same answer. This functions, this is just addition but with negative numbers. Like subtraction breaks the rules of math. It doesn't function the same. Because you can't move your numbers around. You can't switch things around. Like 6 minus 4 and 4 minus 6 are not the same thing. This equals 2, this equals negative 2. But 6 plus a negative 4 and negative 4 plus 6 both map to 2. They both go to 2. Fun little math tidbit. Get your brain toasted, extra toasty, golden brown, right? Okay, let's move on to another example, a different type of example though. I'm going to pull up, ooh, got some weird ringing in my ear right there. That was unusual. I'm going to pull up some different examples here, so give me just 1 second. We're going to move away from distribution and we're going to move towards more just like simplifying things. Or combining like terms. That's what we want to do. Okay. Which we've already been doing, right? But this is going to be more of a purified, just combining like terms type of thing. So we're now on to combining like terms, okay? Like terms. There. Underline it. We're good to rock and roll. So let's do our first example. We'll start off nice and easy, and that is 9r minus 2r. Simplify. What is 9r minus 2r? You have 9 r's, take away 2 r's. That is 7. My 7 looks weird. 7 r's left. So you have 7r, you're good to go. Time to rock and roll. Okay. Let me just delete all of that. We'll write out our next example. It is negative 3f minus 5 minus 6f plus 2. Okay. And I ask you to simplify this And so if I ask you to simplify it, I'm asking you to combine your like terms. Make it so there's nothing else we can change about this problem, okay? So the first step you should do is put your similar terms together. So let's underline our similar terms. So we have the term negative 3f, which has a variable f attached to it. And then we have the term minus 6f, which also has the f attached to it. So both of these have a variable, an unknown, and that's attached to it. We can put these two things next to each other. The other two terms are this negative 5 and the positive 2. They are just integers. We can keep them together too. So they're two different types of numbers. And I hope that makes sense. If this stuff helps you out, if you're understanding it, hit the like button. You can comment. I would love it. I would greatly appreciate it. It would help other people too, which is cool. So let's rewrite this expression where our first two terms are next to each other. So we have, I'm going to take this one first and then this one second. So we have a minus 6f. And the reason why I'm doing it, that one first and that other one second, is just because I like having the bigger number out front. And then the minus 3f, okay. And then we'll go ahead and we'll drop down our next set of numbers, which would be the minus 5 and the plus 2, okay. Boom, we're good. So then we just go through from left to right. Okay, we're going to go through left to right. So minus 6f minus 3f. So you owe someone 6 f's. And then you owe someone else 3 more f's. That sounds so weird. Ah, okay. So minus 6f minus 3f is a negative 9f. And then you have a minus 5 plus 2. Minus 5 plus 2 is a negative 3. And we're good. We're done. Okay? That is our answer. Negative 9f minus 3. So you might, if you're getting better at algebra, you might be like, oh, Paul, can we pull a 3 out of both terms? You could pull a 3 out of both terms, right? And what I mean by that is, dividing both terms by 3. So we could turn it into something like this, right? And that would be fine, but that's not simplifying it though, right? This is not simple. This is good. You got this answer. That's the answer I would want you to get. This answer over here is you're just taking it too far. You're overthinking it. It's fun because you can do whatever you want to these problems outside of a test. That's what's powerful about algebra, is that these two things mean the same thing, right? I could have pulled out a negative 3. So here's another way of writing the exact same problem. Okay, and then that turns into a positive 3f plus 1. So here's 3 different ways of writing the same thing. Very powerful. If I asked you to simplify, oops, messy handwriting. Simplify, okay. If I asked you to simplify, this is the process and this is your stopping point. Because once you start adding parentheses back into it, that's where you're no longer simplified. You're making it more complex. You're making it so there's more stuff to do to it, right? If we leave it at this point, this is like the base. This is like the grassroots. This is like the foundation. And then everything else is modifications of it, okay? Kind of cool, kind of neat. Let's go ahead, black all of this stuff out. And we'll do another example of combining like terms. And then what I think I will do is I kind of want, the other one is called factorize, right? Yeah, yep. So yeah, you can factor things, right? Yeah, you can break things up into pieces. So when you factor something, you're breaking it up into pieces, and that's kind of what that is, where we're breaking that term, that expression up into different terms that are kind of movable again, right? We're pulling that 3 out. We're factoring. Perfect. Good job, export. Good job. Let's take a look at something that's a little bit more challenging, but nope, it's all in the same ballpark of challenging today. It's not too crazy. Actually, let's kick it up a notch. Let's spice things up. Let's simplify a rational expression. This is good to get under your belt. This rational expressions, they are the best way to describe them. They're toxic. Rational expressions can be very toxic in the sense that they look nasty. They are gross looking algebra. Okay? And like this rational expressions, that's what terrifies people. But the same basic rules of all of the math that we've done still apply to rational expressions. So this is going to be just simplifying a rational expression. Okay, let's see, create. Okay, this one looks gross enough. Let's see, I gotta pull it up. I gotta make it bigger though. Okay, so here we go. Let's see how this goes. So we have 10. Let me make that a little bit neater. 10x squared minus 40x plus 30. Oh boy. Okay, I see what we already need to do. And then we have, oh, that's super weird. This is very unusual. This one is weird. 40x squared plus 0x minus 40. You might be wondering already. Like that, I should have, there's a term I said here that should have made you raise your eyebrow. Like, what the heck, Paul? What is this? Okay. Can you guess what term that is? Something should have been like, that's weird, Paul. Why did you write that? It is the 0x. Right away. Let's take care of that. That's nonsense. They were putting that in there to throw you off. That is nonsense. What is 0 times anything? 0 times anything is 0. So don't even play around with that stuff. Don't mess with me, right? They're just pulling you around. So I'm going to rewrite this again. I know it's a lot of rewriting, but hey, if you have paper, it's okay. I mean, what is it? The environmentalist group wouldn't like me saying this, but I mean, in some instances, when it comes to your algebra, it's okay to kill some trees, right? Like, you have a whole notebook. Don't be afraid to write to fill up your pages. Become efficient with your pages, though. Utilize them. Okay. Negative 40x plus 30 all divided by, and now we have 40x squared plus, oh no, not a plus though. See, this plus was tied to this 0x. This term right over here is what we're going to be bringing back over here. So it's minus 40. Okay. Okay. So on this top term, what can we do? We can pull a 10 out. Let's do that first. So let's pull a 10 out. So the way you do that, you put your 10 down, and then you put your parentheses. And so this term divided by 10 is x squared minus, and then what is this term divided by 10? It is 4x. And then lastly, what is this term divided by 10? Plus 3. Okay? So we've completed the top piece. And then, separate from that, what can we do to the bottom term? What's something we can do to the bottom term? We can pull we can pull an entire 40 out because both terms have 40 in them. So you write your 40 out here and parentheses 40. So what is this term here divided by 40? It just goes to x squared. And then this term here divided by 40 is 1. Okay. So far so good. I hope so. It's a little bit weird, I know. Okay. And then this is a super good example. Okay. So this piece right here, we can factor. So it is going to be we'll bring over the let's just simplify this part right here before we move on to anything else. 10 divided by 40, that's another way of writing 1/4. So we'll just keep that 1/4 off to the side and we will continue on. So x squared minus 4x plus 3, that will be, I'm going to do it fast, I'm sorry. I do have a video, I have other past classes if you want to watch those, but it's x minus 3. So what are your factors of 3? And x minus 1. And when you add them together, the minus 3 and the minus 1, you get the minus 4 in the middle term. So we're good. That's our binomial, or that's our two-termed polynomial. Okay. So then remember, this 1/4 is still hanging out front still. Okay. It doesn't matter too much, but it's still that'll just stay no matter what. Okay. Or actually, let me double check. Will that stay no matter what? It doesn't stay no matter what. That's weird. Well, no, that should still be good. Something else is off here. Okay. So then we get x squared minus 1. Now you might be saying, Paul, there's nothing you can do to it, but really there is. X squared, not x squared, sorry, x plus 1 and x minus 1. That's the factored form of this. If you go through and you do this math, you get x squared, and then you get plus 1x, and then you get minus 1x, and then you get the minus 1. Oops. And those two cancel out in the middle. Boom. Yeah. A ton of simplification. And so then this term here cancels out with this term here. And what we're left with is x minus 3 over x minus 3 over x, or x plus 1, sorry, x plus 1. Words matter. Yeah. A lot of factoring. It's kind of backwards from simplifying, kind of. It's weird. They're two different things. I'll say that. They're two different things. 1/4, x minus 3, x plus 1. We're good. We are good. Okay, so if this has helped you at all, hit the like button, comment. Export has been commenting like a machine today, which is awesome. You're taking advantage of me coming on here. I will be taking a break for a little while until my scenery is going to be very different the next time you see me. Yeah, I can do a video on polynomials and working with polynomials. Purple, absolutely. And I was telling Export earlier, I'm going to be leaving the country next week. I'll be leaving the United States for probably like 6 months or somewhere around there. We'll see. 3 to 6 months. I'll be gone. I'll be out of the country. I'll be creating a little travel channel though, and you guys are more than welcome to pop on over there, and you could even message me. And let me put my email in the chat here. So let me double check my email, make sure I give you guys the right one. Where is my email? There it is. Okay, so it is, here's my email. If you guys need any help, you can email me. We'll go with information at tutoru.com. There. Yeah, like, just because for now it's going to be the stream for a little bit. So I think this might be the last stream before you take your test, okay? So honestly, Export, I want you to like email me how you do on the test, on the GED test. That'd be awesome. I would greatly appreciate it. I'm invested. I want to hear that you passed that test. That would be great. And then hopefully I don't get sick. That's the only thing that could stop me from leaving the country, which, knock on wood, I don't get sick, okay? And I'm going to be heading over. I'll be over in the Philippines. I'll be over there. So I'll be bringing my drone. I'll be doing some videos over there. Hopefully my laptop can handle doing the videos. And then I'm still bringing I'll be bringing my sketchpad. So I'm going to try to still do these classes. I'm going to still try to do some tutoring, except for, let me think. It'll be pretty late at night, right? So it is currently over there. It is 12 p.m. right now. Like, if you're in Central Time Zone, right? And the name of the channel, it should be BANAN. Okay, banana ketchup. But for some reason it deleted my channel, I think. I don't know why it would do that, but it did. So I will actually, so Export, let's just plan on having a hangout class tomorrow, like a normal hangout class, like what I usually would do on Fridays. Come back in here, hang out for a little bit, and we can do a little bit of math, but by then I'll have my new channel, I'll have that functioning a little bit better. So then I can actually point you in that direction, because I would love for you to like come, at least, like, I still want to do lives on occasion. I still want to do, me and my fiance, we're talking about doing some podcasts. We're going to be doing videos together while we're over there exploring and everything. So, but I appreciate you. I hope you have a good day. And Export, I'll see you tomorrow. Come back in, hang out. We'll have a good chill time. Take it easy, and I'll talk to you later.